Okay, good morning, good afternoon, whichever the case may be for you. So here we go. We are picking up on section 2.6, day 2, starting with number 9. Today for you guys is September 22nd, and it is Tuesday. All right, here we go. We are going to inscribe a right circular cylinder of height h and radius r in a sphere of fixed radius big R. That's important. Fixed radius. So that's not a variable. It's a constant. We just don't know what that constant is. Some number, call it big R. See illustration. Okay, here's the picture. Here's our cylinder inside of a sphere. Express the volume of this cylinder as a function of the height. Okay, so volume of a cylinder as function of height. Volume as function of height. All right, remembering your geometry. Your honors geometry teachers, had they had you memorize formulas, you would all remember that the volume of a sphere is pi r squared h. You may have just heard the bell ring. That's because I'm recording this today. It's Monday during 5B, so the bell just rang. You're not leaving, you're staying. All right, here we go. So volume is pi radius squared times height. Volume in terms of height. So this h is okay. What we have to get rid of is this little r. We need to turn that into h's. So we're going to have to go back to the diagram and see what we can figure out. Height is this distance from top to bottom of the cylinder. Radius is drawn from the center of the sphere, so it's also center of the cylinder, which means this distance in the cylinder, this right here, is h over 2. We have a right angle here. Did y'all see this right triangle sitting right in here? And looking at that right triangle, we can say that little r squared plus h over 2 squared equals big R squared. All right, now remember, what are we trying to get rid of over here? We're trying to get rid of this r. So that means I want to come over here and I'm going to solve for little r. If I square that first, we're going to have little r squared plus h squared over 4 equals big R squared. We're solving for little r. So little r squared is big R squared minus h squared over 4. Now you could take the square root and get what r is the square root of this mess, but then you'd have to square it when you put it right back over here. So why don't we just leave this as r squared? And we can take that back up here and we can say volume is pi times little r squared, which is big R squared minus h squared over 4 times h. And that's it. You could distribute through, but it's not necessary. You're perfectly fine. You have expressed volume in terms of, or as a function of, h. Remember, this big R is okay in here because that big R is a constant. It's not a variable, it's not changing, it's remaining constant for this problem. So that big R is okay. All right, let's move on over and look at number 10. Okay, water is poured into a container in the shape of a right circular cone with a radius of 4 feet and a height of 16 feet. Express the volume V of water in the cone as a function of the height of the water. All right, so a couple of things here. This is like a big, huge coffee filter. Huge coffee filter because it's 4 feet radius, 16 feet tall, big coffee filter. But when you pour water in, water doesn't automatically go all the way up to the top. We're looking at this level of water right down in here. So that's where this water is that we want to express volume of, as that water. All right, so again, here we go. Volume of the water in the cone volume as a function of height. All right, and I was nice on this one, and I told you the volume of a cone is right there, 1/3 pi r squared h. And again, just like this last one, we're going to have to get rid of that r squared and turn it into h's. So somehow we're going to have to find a relationship between h and r. To do this, you do need to remember your geometry. And let's kind of draw this side in here, this height, this 16-foot height that goes all the way up to the center of this big coffee filter. And you see that we have our big right triangle here. There's a big right triangle. But then also, if I talk about the radius of the water height, we have a little right triangle. And this big radius, 4 feet, is parallel to this radius of the water, r. So we have created similar right triangles going on in here. Do you remember similar right triangles? So that means we can match up corresponding sides. So if I talk about the big container, the height 16 to its radius 4, in the big container, 16 its height to its radius 4 has to be in the same ratio for this little triangle down here, which is the little height to the radius of the water. All right, let's see, let's cross multiply here. And we're going to have, you know what, I'm going to divide this out first. This is 4 equals h over r. Now if I multiply by r, 4r is h. Wait. Which variable did we want to replace over here? The r. Exactly. We want to replace out the r. So that's how I'm going to have to solve for r. So r is h over 4. Now take that h over 4 and come back over here. And we're going to have volume as 1/3 pi times r squared. So h over 4 squared times an h. Let's simplify this one a bit. 1/3 pi times, this would be h squared over 16 times an h. And simplifying even more, we're going to have across the top h cubed times pi, or pi h cubed over 3 times 16, 48. And there we go. There's volume of the water, this blue stuff down here, as a function of its height. All right. Last one, down here on the bottom. Okay. Metro Media Cable is asked to provide service to a customer whose house is located 2 miles from the road along which a cable is buried. The nearest connection box for the cable is located 5 miles down the road. So look at the figure. All right, here's the house. They live out in the middle of nowhere. They are 2 miles straight off a road. Okay? Connection box is here. And the house wants cable. And the cable company has a couple of options. They could run the cable directly from the connection box to the house, right along here. Or they could go down the road, this, and straight up this 2 miles, which is also paved. Well, I don't know if it's paved or not. Yeah, it's off-road. It's considered off-road, so no. So here's the deal. Yes, this is the shortest distance to go from the connection box to the house, but it's $700 per mile when you're going off-road, and this is all off-road. It's cheaper to go along the road because that's the cheaper amount. It costs less money to go here, but you're going to have to go a longer distance to go there. So what we're trying to figure out is there a spot somewhere along here where they could go partially down the road and then partially off-road and hit the cheapest amount of money? That's eventually what's going to happen. All right, so let's look. The installation is 500 per mile along the road and 700 per mile off-road. Express the total cost C of installation as a function of X. C as a function of X. The distance X in miles from the connection box to the point where the cable installation turns off-road. Okay, from the connection box to where we turn off-road. Oh, all right, so this distance is X, right in here. That's X, which means this distance in here is 5 minus X. All right, now, would you agree with me for cost, that's going to be cost on the road plus cost off-road? Cost on the road is going to cost you $500 per mile that you go on the road. Cost off-road is going to be $700 times the distance that we're going off-road. And remember, this is the distance that we're going now. We're going partway down off-road, and then we're going to cut through and go here. Where that red is, that's where we're laying cable. We need this distance. We have a right triangle here. Could use Staggering Theorem. And this right here is going to be this 2 squared plus 5 minus x quantity squared equals that whole distance squared. So that distance is the square root of 2 squared plus a 5 minus x squared. That's a Pythagorean theorem. It's going all in here. 700 times square root of 4 plus 5 minus x quantity squared. Let's just simplify that a bit. It's going to be 4 plus 25 minus 10x plus x squared. Don't forget that middle term here. 500x plus 700 square root 29 minus 10x plus an x squared. There's your final cost right there. C is 500x plus 700 times 29 minus 10x plus x squared. All right, now, so there's the function. Okay, we need the domain. Domain, what kinds of numbers can you substitute in for x? Look back at the picture. Can x be 0? Sure. If x is 0, then we are not going down the road at all. We're going straight through on this shortest distance. Okay, what's the largest thing that x could be? The largest thing that x can be is 5. Can x be 5? Absolutely. If x is 5, I gotta scooch this over, sorry, it got off the screen, I hope that was okay. If x is 5, then we're going all the way down here and then straight up that way if x is 5. So we can include the endpoints here from 0 to 5. All right. I know in part D they told you to do, they told you to graph down in part D. Let's go ahead and start the graph right now in part C. Actually, and we're going to kind of use the calculator to get that. So let's put this in 500x plus 700. Come on, you guys take your calculator out too. Don't just make me do this all by myself here. I mean it. Take out your calculator. Squared. Okay, zoom 6. Oh, it's not there. Oh boy. I'm still graphing. See my cursor? Oh, no, it's gone. It's done. It's not there. So we got to find it. So here's something you can do. Go to trace and then do right there. X is 0. Y is at $3,769. At X is 0.15, we're at $3,700. So we've got some big numbers going on here. So let's leave our X values as they are. Ooh, maybe I could change that a little bit. Because we know X can only go between 0 and 5. So let's drop this down. Let's go -1 up to, say, 6. And Y's, let's send those, let's go -500 to 4,000. Let's see if that's enough. Oh yeah, look at that. Perfect. Maybe we want to see a little bit more Y's so that the graph isn't all the way up at the top. You don't have to do that, but I like to do it. Just bring it down a little more. All right, there we go. So what we can do now for part B, which says compute the cost if X is 1 mile. So just do a value. Second calc value at 1. Right there. $3,630.50. So part B is $3,630.50. Part C, 3 miles. Now you don't have to do second calc value again. You can just hit the next number, 3. And it's going to be $3,479.90. D, graph the function. Okay, got it. What value of X results in the least cost? If we minimize this, I suppose I could have just typed the answers, or the bounds there, but I didn't remember what my scale was. So, what is it? What value of X results in the least cost? So, part D, least cost is X is 2.958. Oops, look at that. So I wasn't paying attention to what I was writing. Sorry about that. X equals 2.958. Okay, there we go. I hope that helps. If you're stuck, we'll try and clean up some of your questions tomorrow when I'm back in class. Have a good afternoon, and I will see you on Wednesday. Bye.